Okay, today we're going to start our unit on graphing, and we're going to first look at the sine and cosine graph, and we're going to look at amplitude and period changes. So a lot of this will seem familiar to you as we get into these changes, thinking back to the chapter that we did on transformations and translations of graphs of functions. Back, I think that was right before Christmas. So you want to kind of think back to that unit, and we're going to apply some of those skills here to our sine and cosine graph. In order to know how to graph sine and cosine, we need to look at the graph and understand a few things. This is a periodic function. So what that means is that this function repeats itself. So you can kind of see from the sine graph and the cosine graph that the graph repeats itself and continues on in both directions, repeating itself. A cycle is one complete pattern. So if I look at the sine graph, this would be considered one complete cycle. After that, it'll repeat itself. So that's one cycle. On the cosine, one cycle looks like this. The period is the length that it takes to complete that cycle. So if I look at a period, the period on the first graph would be here in blue. That's the period. How long it takes, what's that horizontal length that it takes to complete one cycle. Here is the period on a cosine graph. And the amplitude, I think of the amplitude as the height of the peaks and the valleys. So if you think about it, you want to think of the height from the middle or the midline of your graph. So when I look at the amplitude, the height of this peak, you want to think it from the midline, the middle of the graph would be here in red. That's my amplitude. Or here, you can think about it, what's the height of this valley? That's my amplitude. So we're going to change our period and our amplitude today and graph those functions. One thing that's important is to understand how the graph of a sine and cosine is derived, and it's really derived from our unit circle. So if I look at the unit circle and think about these points. So we have the point here of 1, 0. We have the point here of 0, 1, negative 1, 0, 0, negative 1. And these points occur at our axes. So this is at 0, pi over 2, pi, 3 pi over 2, and back to 2 pi. So we're going to look at what our graph looks at these critical points. So at 0, pi over 2, pi, 3 pi over 2, and 2 pi. That gives us our our critical points that we use to graph. So when we're at 0 degrees, if we want to think of this as, we talked about this as really cosine sine, because this is x, y. On our unit circle, the x of our point is our cosine, the y of our point is our sine. So if I look at 0 degrees, and I'm looking at this sine graph here, the sine graph at the sine at 0 degrees is 0. So our first point becomes 0. The sine at pi over 2 is 1, so that's where our 1 comes from. The sine at pi is 0. That's where we're back to 0. So here we're at 0, 1, 0. So then we're at 3 pi over 2. This sine is negative 1. We come down here to negative 1. And then when we're at 2 pi, we're back to 0. So our graph goes back there to 0. We like to kind of think of those 5 main points. With sine, we always start at 0. So you think of starting at 0, going up, back to 0, going down, back to 0. So I kind of think middle, high, middle, low, middle. Same thing here happens with cosine. If I think of cosine, I'll do cosine here in green. My cosine points are going to come from my x values of these points. So at 0, I'm at 1. So I start high with cosine. At pi over 2, I'm at 0. Go to the middle. At pi, I'm at -1. So I go down to -1. 3 pi over 2, I'm back at 0. And at 2 pi, I go back up to 1. Those are my 5 critical points. So cosine, I don't start at 0, I start at 1. Sine starts at 0, cosine starts at 1. So that's just kind of a basic overview. If we look a little closer here, our amplitude on our parent graph is y equals sine x or y equals cosine x. We're not changing the amplitude or the period at this point. The amplitude at your y equals sine x, if we look at it, here is 1 cycle. It has an amplitude of 1. Amplitude is always going to be positive. We want to remember that. Amplitude is really going to be the absolute value of A. Amplitude is a distance, so it's always going to be positive. Period is the length that it takes to go 1 cycle. So if I look at here, here's my period. So my period is equal to 2 pi. My cosine graph, we'll look at that. My cosine graph here is 1 cycle. My amplitude here is 1. And my period, how long it takes me to do 1 cycle, is 2 pi. So now these are our parent graphs. Now we're going to talk about what happens when we change the amplitude and the period. What does that look like? So now we're going to work with y equals a sine b of x and y equals a cosine b of x. So in this instance, the a is happening outside the function. So remember when we talked about that before, when we did our chapter on graphing, when it's outside of the function, those are our vertical stretch and shrinks. So A is going to change the amplitude. Our amplitude is always going to change with that F as that A value changes. And our amplitude is always going to be a distance, so our amplitude is always going to be the absolute value of A. And it's always positive. So that's going to be our vertical stretch and shrink. So you'll remember that back when we did those graphing, if we had something multiplied on the outside of the function, that changed the vertical stretch or shrink. Our horizontal stretch and shrink, which is going to change our period, right? That's going to either it's going to take our 1 cycle either longer than 2 pi or less than 2 pi. Picture that stretching, that graph stretching out. It's either going to take longer to do 1 cycle or shorter to do 1 cycle. That comes with changing B. So B changes our period. And so what we really want to think about when we change our period, the period is written as, to figure out your period, you're going to use a little formula, 2 pi over B. Basically, we say on the basic sine curve, it takes the period is 2 pi. We want to say how much of a cycle occurs in 2 pi. So we take 2 pi and divide it by B. And B is how many cycles occur in that 2 pi period. So we're going to take 2 pi over b. That's always how you're going to find the period. So those are the two things that we want to work with, amplitude and period. The next video that we'll do, we'll get into graphing. This was just an introduction, and then I'll do 3 examples of graphing next.